All right, who would like to share a model you could use to find a common denominator of 1/3 and 1/4? Let's see. Tony, what did you put?
Because the denominators are 3 and 4, you can just do 3 times 4 and that equals 12.
So you can do 3 times 4 and you know that you're going to find a common denominator of 12. Okay, who tried a different way? That's not very good thirds, but you get the idea, right? Thirds there. Can I divide that into fourths now as well? Does that make sense now? Because we can overlap these lines to here. So if we overlapped those two, now how many parts are there? Count them real quick. How many?
12.
So there's the common denominator. So if you fold this paper this direction and that paper that direction, then you can overlap them. Basically, I took this paper and put it over that one, drew the lines, and you can see that I have 12. That's how you do it. Okay. Let's go ahead and we're on 6-5 today. Anaya is planting a flower garden. The garden will have no more than 12 equal sections. 3/4 of the garden will have daisies. What other fractions could represent the part of the garden that will have daisies? So we start working what do I need to find? What is it that we're looking for in this problem? Go back and look at the question and underline what the question is. There you go. Okay, so in the question that they've given us the little sentence here, blank that could represent the part of the garden that will have daisies. What should I be filling in there, Angelique? What number? What fraction? What fraction, right. What other fraction? So, I'm just going to put fraction that could represent. Go ahead and write it in. What information do I need to use? It says blank of the garden will have daisies. What fraction will have daisies, class? 3/4. It tells me right here. The garden will not have more than how many equal sections? 12. It tells me that right here. How am I going to figure this out then? Has anybody already thought about how they would go about solving this problem? Because I thought about it. I looked down there and I could see. But I thought about it too. Sean? Draw a model, right? So let's do, I can make a model to find the fractions, I guess, or all fractions to solve the problem. That fraction. It's a table of models, right? Okay, so if here's the garden, and the garden has 12 equal sections, and we know for sure that you can divide it into fourths. So they've taken they drew a garden, and they've divided it into fourths, first of all. You see that so far? Okay. We need to make some equivalent fractions that have no more than 12 equal sections. So how can I divide this garden further to make equal sections? They all have to be equal. Any ideas where I can draw a line? Sideways through right here, the middle? He says this should say equivalent. Okay, so anyways, here we go. How many equal parts are there? Here. 8. Remember, we're not counting little boxes. We got confused when we did the Browning question. We're not counting little boxes. We're counting, this is one section right here. So there's 1, 2, 3, 4, 5, 6, 7, 8 equal parts. How many are shaded?
3.
No. Think, stop. Don't just yell out. Count them and raise your hand. How many of those sections are shaded, Sophia?
6.
6. Now, knowing what you know about equivalent fractions, can you see from here to here, is it an equivalent fraction?
Yes.
Yes, it is, because 4 times 2 equals 8, and 3 times 2 equals 6. Okay, what is another way I can divide this? Am I going to go a vertical line or a horizontal line? This is a horizontal. These are vertical. A vertical. Okay.
Like in the middle of the.
Right here.
Yeah, like that.
And keep doing this. Okay. How many equal parts does that have now? It's the same. So it's the same equivalent fraction. So how can I make a different split so that I have an equivalent fraction, Andy?
You draw 2 lines horizontal in the middle.
So horizontal, make them even, right? Because we have to have the correct, like that? Is that what you're thinking? Do I have equal parts?
Yeah.
Take a second to count how many equal parts there are there. Everybody should be counting. Luna. Horace, how many equal parts?
3, 12.
12 equal parts. How many of them are shaded? Count. How many of those are shaded? What'd you guys get?
9.
9. Okay. Can I get from my first fraction to this equivalent fraction?
Yes.
How would I? By multiplying by?
3.
By 3. 3 times 4 is 12. So I do 3 times 3 up here, and that equals 9.
Wow.
Okay. My parameters for this problem were that I could have no more than 12 equal sections. I do have 12 equal sections, but I don't have any more, so that would work. What could I have done? 4 times 4 and 3 times 4. 4 times 4 is 16. This is an equivalent fraction. Would this have worked? Who can explain to me why that one would not work? Rachel.
The denominator is over 12.
The denominator is over 12. And it told me that the problem says it can't be more than 12 equal parts. All right, so I'm going to get rid of that one. What other fractions could represent the part of the garden that will have daisies? So we just did, what were they? 6, 8, and
12.
it asks you to explain. Explain in words why those fractions work. Okay, go ahead and take a second to do that on your own. Daniel.
6 eighths and 9 twelfths work because they're equivalent to 3/4, and the denominator isn't over 12.
Very good. So 6 eighths and 6 eighths and 9 twelfths work because they are equivalent fractions of 3/4, and the denominator is not over 12. Two friends are knitting scarves. Each scarf has 3 rectangles, and 2/3 of the rectangles have stripes. If the friends are making 10 scarves, how many rectangles do they need? And how many rectangles will have stripes? First of all, I'm so lost by this problem. It's like rectangles and 10 scarves and 3 rectangles and 2/3 have stripes. Is there anybody else who's looking at this going, I don't even know where to start? Okay, so what I'm going to do to help me is I'm going to draw a scarf. I'm going to start with what they gave me as the directions for the scarf. So here's my scarf. Okay? The scarf has how many rectangles? 3. So I'm going to make the 3 rectangles. So now do you see so far I have a scarf with 3 rectangles. 2/3 of the rectangles have stripes. Do I have 3 equal sections?
Yes.
My denominator is 3. So this works already the way I have it set up. How many of them have stripes? 2. I'm going to go ahead and guess that they probably do the outer 2 and not the inner one. Okay? Looks like a Band-Aid. So there's my scarf. It has 3 rectangles. 2/3 of the rectangles are stripes. How many of you are feeling a little less scared about this now? I feel less scared because now it's starting to make sense to me. Do you see how a simple drawing that was pretty easy to come up with will help you with your problem? So if it sounds scary like it did to me, that's what you should do. All right, now I'm going to go back to the clues that it's giving me I should do. It says, what do I need to find? What is the question in this question? What are they asking you to find? Who can tell me? Brian.
How many rectangles do they need?
Right. How many rectangles will have stripes? Go ahead and underline that and write it in here. What is some of the information that I'm going to use in solving this problem? What is some of the important information, numbers and things like that? Yes. There's 10 scarves. Okay. What else? More. Preston.
It has 3 rectangles.
Each scarf has 3 rectangles. I'm going to draw a rectangle so I don't have to write it. Okay. Owen? 2/3 of the rectangles have stripes. Okay. And then the last thing is, how will I use this information to solve my problem? Any ideas? How about a table? I'll show you what I mean. I'm going to solve the problem down here. Whoa, that's very ugly lines. I'm going to start with the number of scarves up here. I'm going to put rectangles with stripes. I'm going to just draw it this way. With stripes over total rectangles. Okay, so here's how that works. Let me show you what I mean. If I have one scarf, how many rectangles have stripes?
2.
Out of how many? 3. I'm not going to do that. My fraction is 2/3, right? One scarf has 2 of the 3 rectangles have stripes. So if I have 2 scarves, how many rectangles total do I have now?
4, 6.
6 rectangles, because I had 3, so this time I'm going to have 6. How many are going to have stripes?
4.
4. I'm making equivalent fractions now. So you have to visualize in your head. If one scarf has 3 rectangles total and 2 are striped, right? What if I made another one? Okay. So now I have how many rectangles total? 6. And how many are striped?
4.
Is this an equivalent fraction to this?
Yes.
Who could explain why it's an equivalent fraction? Preston.
Because if you times the first scarf by 2 and equal
The next. Okay. So 3 times 2 is 6. And 2 times 2 is 4. So I've just made an equivalent fraction using this number up here to help me. Let's look at the next one. What's my next scarf? My 3rd scarf, correct? What if I multiply my original fraction by 3? The denominator will be 8 or 9?
9.
9, because it's 3 times 3. So 9, and the numerator will be
6.
3 times 2, which is 6. Okay? my fourth scarf. Let's find an equivalent fraction. I want you guys to think about it. 4 times the original denominator is 4 times the original denominator is 12, not 16. 4 times the original numerator is... Okay, I see a lot of you kind of just hanging back and being lazy about it. You have to participate. I see some people who aren't even looking. Let's do the next one. Our fifth scarf.
10.
Okay, I want you guys are just yelling out numbers. I haven't even asked a question yet. 3 times my original denominator.
15.
I'm sorry. 5 times my original denominator.
15.
15. 5 times my original numerator.
10.
10. Okay. Do I have to continue this table or can I just skip to my 10th scarf? Now that we've kind of figured out a pattern, we know what to do. It's my 10th scarf. 10 times the original denominator.
30.
10 times the original numerator.
20.
20. Can I find out now, back to my question, how many rectangles will have stripes? Here is my column that had how many rectangles would have stripes. Can you look at my table now and answer that question? If you can, raise your hand. How many are going to have stripes? Raise your hand if you can tell by my table. How many?
20.
20. So 20 will have stripes. Go ahead and fill this in. And I want you to answer the question number 2 while you're doing that. Does your answer make sense? And explain how you know that it does. Okay, so she says it makes sense because we kept multiplying the numerator and the denominator to get our answer. What do we call this fraction compared to this fraction? What do we call those two fractions there? Equivalent fractions. So it does make sense because they're equivalent fractions too. All right, let's go ahead to the next page. Okay. Keisha is helping plan a race route for the 10-kilometer charity run. The committee wants to set up the following things on the course. So think about a charity run. Maybe you're picturing a track. Maybe you're picturing a road that's just a long stretch of road. But picture in your mind what a course that you would be running might look like. There will be a viewing area, a place for people to sit and watch the runners run by. It will be at the end of each half of the course. So at one half and then at the end. So each half of the course is going to have a viewing area. There will be water stations at the end of each fifth of the course. So if you took the road and you divided it into fifths, at the end of each of those fifths, there's going to be a what? Water station. I see some pencils still moving. They need to stop. And the last one is a distance marker. So as you're running, you will know how far you've run at the end of each 10th of the course. So if you take the course and you divide it into 10 sections, equal sections, at the end of each of those sections, it will have a marker that shows you how far you've already run. The question that they're going to ask here is which locations will have more than one thing located there. So at what point are you going to see, hey, there's a viewing station and a water station here, or there's a water station and a distance marker here? Where are you going to see more than one marker? Okay. The way that they gave you an example is to draw a table, and they've already set it up for you. First, they talk about the viewing area. It's at the end of every half of the course. There you go. Thank you. So how many places are going to have a viewing station? It's divided into halves. So how many sections are there, Jaden? Two. So there's going to be a viewing area in two places, and they've already done that for you. The first one is going to be at the half mark. It gives you the fraction, every half mark. What about the water stations? It's going to be split up into how many sections? It's going to be split up into 5 sections. So there will be 5 areas that have a water station. The first one is going to be at the 1/5 marker in. Okay? And the last thing is the distance markers. It says every 10th, at the end of every 10th of the course. So there's going to be how many? 10. I mean, you're thinking how many equal parts. It's telling you in the denominator how many equal parts there are. So the first one starts at 1/10. Now, just like we do with common multiples, we keep finding the multiples until we find the common ones. We're going to do something similar with our fractions. Okay? So let's first look at this. All of the locations that will have the viewing areas, we're going to have them at 1/2. What's going to be the second location that it is? What do you think, Antonio? Not 2/4, because 2/4 is still a half. We're not doing equivalent fractions. We're doing the next fraction. Haley? Not 1/4, because that would be going backwards. Jaden? 1/2, right? At the end of it. And if we kept the same denominator, a whole looks like this. 2/2 means 1/2. Okay? And I'll put that like this, which means 1. Let's look at the next one. If the first one is at 1/5, what's the second one going to be at? Remember, we're not looking for equivalent fractions. We're looking for the next marker. What do you think? 2/5. Very good. What is the next one going to be at? Everybody.
3/5.
3/5. I had some 2/10. But we are going, let's look at what this looks like. If this is my track, and I've divided into fifths, I get to here, that's 1/5. This would be 2/5. Now I'm at 3/5, and then I'm at 4/5, and then I'm at 5/5, which is 1/2. Okay. Now looking at tenths. The first one's at 1/10, and then 2/10, 3/10, 4/10,
5/10, 6/10, 7/10, 8/10, 9/10, 10/10.
1/2. Okay. So let's start with the obvious. Which spot is going to have at least 2 markers or stations or something? Which one is going to? Andy? Well, the viewing areas is going to be at the half and the 1/2. Which one is going to have all 3? The 1/2, right? So I'm going to circle this. That's one area. So we're going to have the end, the finish line. That's our 1/2. Now we have to start looking at, this is a half. Are any of these fractions equivalent to a half? And can they even be equivalent to a half? Can you have half of 5? No. So can any of these be equivalent to half? No. Are any of these equivalent to half?
Yes.
Which one's equivalent to half? Right, 5/10 is equivalent to that half. So at the half mark, there's going to be 2 stations. Okay. Now I've compared all the fractions from the first one. I did 1/2 and 1/2, so there's definitely going to be more than 2 things at the half and the end. What about equivalent fractions from here to here? Is there any of these tenths that are equivalent to 1/5?
No.
I want you to look at it. Do you see any of, is 1/10 equivalent to 1/5? No. They're totally different. I'm going to cross that one off. What about 2/10?
Yes.
That is actually equivalent to 1/5. So at the 1/5, we are also going to have 2 markers. What about the 2/5? Do you see any equivalent fractions to 2/5?
Yes.
Raise your hand when you find one, if you find one. Nicholas. 4/10 is equivalent to 2/5. So at the 2/5, we're also going to have some. What about 3/5? Are there any equivalent fractions to 3/5? Jaden?
6/10.
The 6/10 is equivalent to 3/5. What about 4/5? Are any of those fractions equivalent to 4/5? What do you think, Bella? 8/10 is equivalent. So at the 4/5, we are also going to have 2 things set up. Okay, I've just gone through all of these and all of these. I don't need to go through the last group because I'm not going to be comparing it against anything else. I've already compared it against the other ones that it could be. So, identify the locations at which more than one thing will be set up. So they will be at the half, the 1/5, the 2/5, the 4/5, and the end. Let's make it real fun. Which one of those will come first? Think about it. Will the end, the half, the 1/5, the 2/5, or the 4/5 come first as you're running? This is tomorrow's lesson. But I just thought I would throw it out there for you. What do you think, Daniel?
1/5.
1/5. Very good. It's the smallest piece. 1/5 is very small. It's less than a half, isn't it?
Yes.
Okay, and it's less than a half. It's less than the end. That's gonna go over here. That's obvious. I called it the end. Okay, 1/5 is smaller than a half. It's smaller than 2/5 because 2/5 is 2 of them and 1/5 is only 1 of them. So what's gonna come next? What do you think, Horace? 2/5. 2/5 is still less than a half. How do I know that? We'll talk about it tomorrow because that is a whole different lesson and I don't want to confuse you. And then the end is the order that you will find those. Okay, the next question says, what if distance markers would also be set at the end of every 4th of the course? So, will any of those markers be set up at the same locations of this? Hopefully yours was a lot neater than mine if you wrote it already. What I want you to do is add in distant markers. We're going to have, this is the second group. If they're set up at every 4th, how many will there be total?
2, 8.
No. Think about it. If they're set up at every 4th of the course, how many total markers will there be? Not 2. It's every 4th. Owen. 4. At the end of each 4th. So you need to find, the first one is going to be 1/4. The second one will be 2, not 2/8. We're not doing equivalent fractions. Remember, we're taking our course like this and splitting it into 4ths. The first one ends at 1/4. Then the second one is 2/4, and the next one is,
3/4.
and then 4/4. I want you to see if you can find where the question is, will any of these new markers be set up in any of the other locations? Same location as any of the other ones. Yes, there will be, so don't start shaking your head. You need to work it out like we just did here. So work on that on your own. Actually, I'll let you work with your elbow partner. Which locations on the 4ths will share a location with something else?
The 4/4 and 2/4.
4/4 and 2/4. Who got 4/4 and 2/4? Stop. Get your hand down. Thank you. Lydia, can you explain to me how you did that? Mm-hmm. Okay, so you did 1/4, 2/4, 3/4, 4/4, and then how did you compare them? How did you know that there would be markers at those two spots? Well, this one right here, what is the 4/4? What location is that? Everybody.
The end.
The end. This is the end, and we've already decided there's some markers at the end. What is an equivalent fraction for 2/4? Brian?
1/2.
1/2, right? And we already decided that there is another location that's 1/2. Okay, the other two fractions we had were 1/4 and 3/4, and you had to ask yourself, were any of those equivalent fractions to this big old mess over here? And you can't, because you're talking about fourths and tenths and fourths and fifths, and they don't work. Okay, so the only one that would work here is the 1/2 and the end, as far as the locations you'd find out.